Hey guys, this is a review on graphing lines. So something you've done for a couple of years in math class, but I think there's some vocab maybe we need to review. So the first set of questions, they're going to ask you to identify the slope and the y-intercept, and that is all they want. So I usually like to start identifying what's called the y-intercept for our line or any function. It's where the line or function will cross the y-axis. Now this one's a little misleading because we didn't finish the line up here. But that seems to be where it's crossing the y-axis. So our y-intercept is located at the ordered pair 0, 5. Now slope, you might remember from your previous class, a few different formulas, rise over run, change in y over change in x. So what I like to do first is figure out whether the slope is positive or negative just by the look of the line. So since this one is decreasing from left to right, we're going to have a negative slope. So I'm going to go ahead and write that sign down. But at this point, I do need to count a little bit. It'd be nice if they identified some clear points for us. So I'm going to start at this point, and then the next obvious point I see is down here. So if I travel, rise over run, remember, is vertical over horizontal. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8 down, and then 1 to the right. So your slope is -8 over 1. Which most of the time we just write -8. So for number 2, same idea, you need to identify both pieces. So I'm going to start with the y-intercept. So where the line is crossing the y-axis is right here at the ordered pair 0, -3. And then our slope, I'm going to use that as my starting point. And don't be misled, this is not actually going through the point 1, -2. Keep looking. Looks like it goes through that point. So if this was something on a quiz, I would clearly identify which points I want you to count from, so that way there's no misleading you. So we're going to count rise over run again. This time I notice it has a positive slope. So I'm going to go ahead and put down a positive sign. And then 1, 2, 3, 4 up. 1, 2, 3, 4, 5 to the right. So up 4, right 5, positive 4 over 5 is our slope. But now they're going to want us to actually sketch the line. And the reason we started with identifying the slope and the y-intercept is because that's the quick method of graphing a line in this form. If you could start at your y-intercept, drawing a point. So here our y-intercept is at 1, meaning I'm going to plot the point 0, 1. And then your rate of change or your slope tells you how to move to get another point. So if your slope, which for some reason in math we use m, is a +1 over a +2, that means we're going to travel up 1, and we can travel right 2. So up 1, right 2. I could keep going. But remember, slope, because you could move the other direction, right? We could move down 1 and left 2. The reason that is still a positive slope is because of the 2 negative rule in math. If you take a negative number divided by a negative number, that's still going to be a positive number. So sometimes you'll find out that you're going to run out of room on your graph, and you got to get creative. We're all in for a good time when I try to graph a line. Oh man, I missed every single point. Close enough. Alright, there's my line. So before I walk away from this question, I just want to make sure that it looks appropriate. I'm looking for a line that crosses the y-axis at 1 and has a slope of up 1 over 2, a positive slope, which is what we have, so I'm going to move on. Now this next line is a special case. It just says x equals 1, and you'll notice it doesn't follow that same formula of y equals mx plus b that we had been seeing. So that means it's either a vertical line or a horizontal line. And the easiest way for me to remember this is just to think about what it's saying. It's saying x is always equal to 1. So if I go over to the x-axis and I draw a point at 1, the line I'm about to graph has to go through that point. So the only, oh my gosh, all right, pretend that's a line. The only line that would work would be a vertical line through x equals 1. And you'll notice every single ordered pair that I could possibly plot along this line would have an x value of 1. Now, contrary to that, if you had y equals a constant, which you're probably going to see in your homework, that would be a horizontal line that goes through the y-axis. Okay, number 5. Back to some quick graphing lines in slope-intercept form. So we still are starting at our y-intercept, so this time our y-intercept is at the ordered pair 0, -1. And then your slope, your rate of change, is -1 over 3. So I like to keep the signage, if it's negative like this, I like to keep it with my vertical movement, just so it stays consistent for me. So I'm going to use the negative with the 1, which means instead of moving up 1, I'm going to travel down 1 and right 3. So if I travel down 1 and right 3, that would create this negative slope line that I'm looking for. Now, also, I could have moved up 1 and left 3. That still would have been a slope of negative 1/3. But I don't need to graph 3 points. I only need to graph 2. See, I forgot I have this. I have a tool that draws lines for me. There we go. The only thing I need to improve upon here, though, on this tool is it doesn't give me arrows. So I'm going to add arrows to each end. Make sure when you're graphing a line that it's big and bold and it has arrows on both ends. All right, this next guy tricks kids because they think it's one of those weird lines that is either horizontal or vertical. But because there are both the x and y variables, we don't have that. We're going to have a diagonal line like we have been having in most of them. The only difference is I notice there's no y-intercept listed, which means it's going to go through the ordered pair 0, 0 for your y-intercept. So this time our slope is 4/5. Notice positive, which means I could travel up 4 and right 5, and that would give us a slope of 4/5. So 1, 2, 3, 4, 1, 2, 3, 4, 5. Contrary to that, but still the same slope, I could move down 4 and left 5. That would still be positive. But really, you only need 2 points to make a line. And now that I know I can use this, I'm going to use it every time because I can't graph. There we go. Add arrows to the end of your line. Step back and look at it. Make sure you have a line that's going through a y-intercept through the origin. And your slope is positive 4/5. So these next couple questions, it's kind of a vocab question. They're going to tell you you have an x and y intercept at specific locations. And because those are 2 different points, that's going to be enough for us to graph our line. So think about your vocab. An x-intercept would be a point at which the line or the function would be crossing the x-axis. So x equals 1 means that our line is going to go through that point right there. And then a y-intercept of -4 means our line is going to go through that point right there. So by our geometry definition, I have enough to make my line. I'm going to do that. Yep. Ooh, that's ugly. So there we go. We have a line. At this point, if my teacher asked me to create an equation for the line, I sure could, but that's a thought for another problem. All right, same idea here. We have another x-intercept. So x-axis at -3. And then, oops, hello. We have a y-intercept at -1. So y-axis, -1. That's enough to draw a line. And there we go. Add arrows to both ends. And again, if my teacher wanted me to create the lines equation, I could. But we're going to hold off on that till another day. Okay, so 4x minus 3y equals 12. This line is in what we call standard form. And at the very least, it's not in our friendly quick graphing form of slope-intercept form. So in order to graph this line, I have 2 methods. I'm going to show you both, and you're going to have to decide which method you like best. So method number 1 basically says, I'm going to take my form, and I'm going to rewrite it into a form that I'm more familiar with. So we're going to rewrite it into slope-intercept form, which is y equals mx plus b. So using our vocab from Algebra 2, we are going to isolate the y variable. So if I think about how I isolate for y in this problem, I'm going to start by moving the x term to the other side of the equation by subtracting 4x. Now I know earlier in the chapter when I let you isolate, it was really a free-for-all as far as how you wrote your answer. So maybe you were about to write -12 minus 4x. That wouldn't be wrong, but if I kind of think about what I'm trying to do in this problem, I'm going to want to graph it in this form. So I'm actually going to flip that order around a little bit. I'm going to write it as -4x minus 12. So that way the term that has the x and the slope is going to be before the constant. All right, but we're still not quite isolated. We have one more step here. I'm going to divide every single term by -3. And again, it was a free-for-all earlier in the chapter, but because of what I'm trying to do with this question, I'd like you to divide each term by -3 separately. So I think we're ready to produce a line that is in the form we like. which is slope-intercept form, I do have to do a little bit of simplification. Negative 4 over negative 3, that slope is going to reduce to a positive 4/3. And then negative 12 divided by negative 3 is going to reduce to a positive 4 for your y-intercept. So that's one method, and then we would use our quick graphing method that we've been using. The other method is, and this only works, well, it works with every form technically, but it works really nicely with standard form. You're going to find your x and y intercepts, and we know from our previous question, if we know what our x and y intercepts are, that's 2 points that we could use to plot our line. So when I go to find an x-intercept of a function, we know that's where the function is going to, or where the, in our case, a line is going to cross the x-axis. So if I think about any ordered pair along the x-axis, the y value is a 0 because there's no height there in that axis, right? So what that means for our math is if I took my original equation, so 4x minus 3y equals negative 12, and I know that the x value is going to be a 0, so imagine evaluating this with x equals 0. This entire term is just going to be, it's going to become a 0, so it's no longer even, you don't have to consider it. So our remaining equation is negative 3y equals negative 12. And if I asked you to solve for y, you would just do a quick divide by negative 3 on both sides. And we would find out that the y, oh my goodness, look what I just did. I'm not re-recording this lesson, guys. I plugged in for the wrong number. Okay, back up, Abruzzo. You were supposed to plug that in for the y. Right there. So if that term was a 0, now we have this tiny equation, 4x equals 12, negative 12. And doing a quick divide by 4 on both sides, we get x equals negative 3. So that, if you get really good at these, you can do that step in your head as long as you're doing the right thing and not doing what Mrs. Abruzzo did. Okay, so we're going to go find the y-intercept, which I actually already found by accident. But same idea, we know that anything on the y-axis is going to have an x value of 0. So if I go back up to my question here, probably shouldn't have erased it so aggressively. Here we go. And I were to substitute in x equals 0 right there, this entire term is gone, and now you're left with a tiny equation of negative 3y equals negative 12 that you could solve for y, and you would find that y equals 4. So now I have 2 points I can plot. I know my x-intercept is at negative 3, and I know my y-intercept is at 0, 4, and that's enough to plot. Now, I don't think I sold anybody on that second method because I messed it up so bad. But I will tell you, a lot of kids, as they progress in math, find that the intercept method for standard form is pretty quick, and they like it a lot. And as your teacher, I'll tell you, a big source of error for kids in isolation is dropping negative signs and not simplifying properly. So as you practice these, you have to kind of decide what method you want to go with and which one you're more accurate with. Clearly, I'm not accurate with either. All right, let's try this last example here. This is not necessarily in any form that you might be familiar with, but the point is it's not in a form that I can graph right now, so I'm going to need to rearrange this. I notice in this problem there's only a y, so that's kind of telling me I might want to get this isolated, this y isolated. So there's a couple different ways we can do this. A lot of kids think they're going to add the 4 over, but if you do that, you still have to divide by a -1 coefficient. So then some wise kid in our class is going to tell me, why don't we go ahead and just add that y over. Now I'm going to rewrite over here because I'm out of space, but now my formula says y equals -4. So this is one of those special lines. And I think about whether this is horizontal or vertical. And if I go over to the y-axis, and I plot a point at -4, and I draw a line through that, I'm going to have a horizontal line. Don't forget your arrows. All right. So notice that equation was not really in a pretty form, and they do this a lot on your SAT test. Well, they'll give you what should be a really easy question about matching graphs, but the equation itself is not in a familiar form. So sometimes you have to do a little rearranging before you can find those pertinent pieces. You know, what's my y-intercept? What's my slope? All right, hope that helped. We're going to practice this a little bit in class so we can move on to inequalities.